In this section, we're going to take a look at one of our other techniques of being able to evaluate integrals. And this is an important one because we're going to be using this one quite frequently throughout the semester, integration by parts. Suppose that you go to integrate some sort of integral, and unfortunately that you can't integrate it by basic methods and a u substitution doesn't necessarily work. Then what we can do is we can use another formula to be able to try to evaluate this. So this kind of goes back to differentiation, where there's a rule for derivatives, all right, but it only works for these specific types of integration by parts. Go back to Calc 1 and recall that the product rule states that the derivative of the product of two functions is equal to the derivative of the first times the second plus the first function times the derivative of the second. Let's try to manipulate this formula to be able to get to some sort of integration by parts formula. So what I'm going to do is I'm going to integrate all of the terms. So I'm going to integrate d dx of f of x g of x. And I'm going to integrate the right-hand side. And I'm going to integrate these all with respect to x. So I'm just going to throw a dx in there as well. So integral of f prime of x, g of x, dx, plus the integral of f of x, g prime of x, dx. So that's integrating all the terms. Now, the fundamental theorem of calculus suggests that if we integrate a derivative, those will cancel out. All right, so they're inverse operations. So what we're going to be left with is f of x, g of x, equals integral f prime of x, g of x dx, and then plus integral of f of x, g prime of x dx. Okay, so just a really basic sort of operation there. Now what we're going to do is we're going to isolate this term, and we're just going to subtract the integral of f prime g of x d of x from both sides. And so we wind up with this. We wind up with f of x g of x minus the integral of f prime of x g of x dx is going to be equal to what we have on the right-hand side right here. Integral of f of x g prime of x dx. Now, what we can do to abbreviate this formula is let's let u be equal to f. So where you see f, that's going to be equal to u. And that means that u prime is going to be equal to f prime dx. And everything's in terms of x, so it's a derivative with respect to x. Let's let v be equal to g. And that means that v prime is going to be g prime dx. And so if I substitute that back into the formula, so I'm going to get uv minus the integral of du, so that's f dx, and we know that g is v. And then on the right-hand side, that's going to be u dv. That's precisely what the formula is going to be for our integration by parts. U dv equals uv minus v du. So we just basically took a few moments to derive the integration by parts formula, which is going to be important because we need to know where it comes from. So when we're integrating by parts, all right, what we're going to do first is we're going to define u and dv. All right, so we're just going to pick one of the factors to be equal to u and the other factor to be equal to dv. Now, generally when we do this, we want to pick the u so that when we differentiate it, it'll try to reduce in order, okay? That's not always possible, all right? But if we could pick like a polynomial term or something we know that's going to reduce a little bit, then that should be u. And dv should always be integrable, because to be able to find v, we're going to have to integrate, all right? So we're going to have to find du, all right? So just like we would find, so we would have u is equal to some function, and we would have dv is equal to the derivative of that function. And so what we're going to do is we're going to find the antiderivative to find g, and we're going to find the derivative to find f prime. And we'll see some easy examples of this in a few moments, right? Finally, once we have all four of these, u, v, So we just have u times v and then v du. We just multiply those together and plug it back into the formula to be able to evaluate the integral. So let's take a look at a really basic example of this. All right, this is probably one of the easiest examples and one of the most common examples of integration by parts, x e to the x dx. We're going to define u to be something that's going to go away when we take its derivative. We know that when we take the derivative of x, it's 1. With respect to x, it'll be 1 dx. We're going to define dv. And in this case, the only thing dv can be is e to the x dx. We take the derivative of x, and that's going to be 1 dx. We take the antiderivative. Okay, so right here, this is the derivative. This is the antiderivative, all right, to be able to get to v. And we can't mess this one up. The antiderivative of e to the x dx is e to the x. Our formula, integral of u dv is going to be equal to uv minus the integral of v du. So that's our formula. If we plug everything back in, this is just the original integral all the time. Okay, so that's just going to be the integral of x e to the x dx, u times v. So similar to maybe what we did in calculus 1, for those of you guys that did this method. In calculus 1, you might have done something where you cross to be able to use the product rule. So uv is going to be x e to the x minus the integral of v du, or e to the x times 1 dx. Now I'm going to put plus c1 because there is a constant of integration because it is an indefinite integral. We're not done, but we're almost done. And what we're going to do is we're just going to evaluate this integral that's left over, which is e to the x dx, a very basic integral. So one possible solution would be x e to the x minus e to the x. And since it's the second iteration of an integral, I'm going to call it c2. However, if you just want to call it c, for some reason, if MyMathLab or something like that wants it as c, then that's how you would try to enter it. All right, and this is it. This is your answer. You could certainly factor out the e to the x. So another possible answer could be e to the x quantity x minus 1 plus c. And as we know, the factored form might be a little bit more beneficial to evaluation. So for instance, if you were trying to find the area that's bound by the function between two specific points, this might be a little bit easier to do so. Right. So for the rest of this section, we're going to take a look at the various techniques that are necessary to be able to integrate by parts. This was a very basic problem. As we go through, we're going to look at other sorts of techniques and more difficult problems with respect to this sort of this technique.